Over the next couple weeks, we'll be focusing on translating sentences from natural language, English in particular, to sentences of the formal language that I've just described. After we get a handle on translation, we will then turn to understanding semantics in much more detail, and in particular also be able to give a detailed theory of validity. But before, but I want to now give a brief introduction to the notions of semantics, which we will explore in much more detail in a couple of weeks, because I think having some idea of what they are will help with understanding why we're doing this translation, and it will also help us do translation. So in this video, I'm going to quickly talk about the meaning of the connectives in our formal language. So the thing to understand is that the connectives are truth functional. What that means is that the meaning of sentences formed using them is determined by the meanings of the constituent sentences. And we will treat the meanings of sentences as truth values. And we will come back to this in much more detail in a couple of weeks, but what is important, what this means is that we can treat the meanings of connectives with things that are called truth tables, okay? So we can give the meaning of a connective like conjunction or disjunction with what we'll see as a truth table. And what the truth table shows is how the meaning of a complex sentence built up using the conjunction, say, or disjunction, is a function from the truth values of the sentences which it's built out of. So the meanings of connectives are functions from truth values to other truth values. And these are functions in the mathematical sense. What you do is you have an input, you input the truth values of the constituent sentences, and the connective tells you the truth value for the whole sentence. So that's a typo here in this last sentence here. So this should read that when you input the truth values of the constituent sentences, the connective outputs a truth value for the whole sentence. So I'm going to go over what this means in particular with regard to the different connectives which we introduced in the previous lecture. So we begin with negation. So negations are sentences which have the negation sign at the beginning. So for instance, something with the form not phi. A negation or negated sentence is true just in case the negated sentence is false. So the sentence not phi is true just in case phi is false. So that is to say that the negation not phi is true when phi is false. And otherwise, if phi is true, then not phi is false. So we can represent that with the following truth table. So when the sentence phi is true, the sentence not phi is false. And when the sentence phi is false, the sentence not phi is true. So that is how we represent the meaning of negation. It combines with the meaning of a negated sentence and gives you a new meaning. And in particular, for us, the meaning of sentences is a truth value. So given an input truth value for the negated sentence, negation tells us what the overall truth value of the negation is. Here's how conjunction works. So conjunction has to do with and sentences. So for instance, sentences of the form phi and psi. And a conjunction, this entire sentence phi and psi is true just in case both conjuncts are true. So in order for this entire sentence phi and psi to be true, both phi has to be true and psi has to be true. And if either phi or psi is false, then the entire sentence is false. And this is represented by the following truth table. So because for conjunction, we have two constituent sentences, right? So for negation, we have a single constituent sentence. So the truth table simply lists the possible truth values of the single constituent. For negation, but for conjunction, we have two constituent sentences. And so the truth table is a bit more complicated. And what we list is on this left-hand side of this truth table is all the different combinations of truth values for the constituent sentences. And then on the right-hand side, we list what the overall truth value of the entire sentence is on that basis. So when both phi and psi are true, the overall sentence is true. But in all the other cases where one of phi and psi is false, the entire sentence phi and psi is false. So that's how the meaning of a complex sentence phi and psi is determined by the meanings of its parts. And again, we're thinking of meaning as truth value. Now for disjunctions or sentences with or, what we say is that a disjunction is true just in case either one of the disjuncts is true. So that means that a sentence of the form phi or psi is true just when either phi is true or psi is true. So with conjunction, we require for the sentence phi and psi to be true that both of the constituents are true. When we say phi and psi, we require for that to be true that both phi and psi are true. When we say phi or psi, we just require that one of those two things is true. And so the disjunction is false when both phi and psi here are false. And so as discussed in the readings, this notion of disjunction is inclusive. Okay, so if both phi and psi are true, phi or psi is true. And we represent all of this in the following truth table. So again, because we have two constituent sentences, we list all the possible meanings or truth values for those two sentences. And we say for each of those cases, what the overall truth value of the disjunction is. And as we said, the disjunction phi or psi is true in every case in which at least one of these two things is true. So when they're both true, it's true. When phi is true, the overall sentence phi or psi is true. When psi is true, the overall sentence phi or psi is true. But in the case where both phi and psi are false, the disjunction is false. But in all other cases, the disjunction is true. And to say that disjunction is inclusive is to say that in the case where both phi and psi are true, the disjunction as a whole is true as well. So the conditional sentences like if, then formalizes phi right arrow psi. This conditional works as follows. And the conditional is a bit tricky, and we'll come back to the details of this in a couple of weeks when we actually study the semantics in more detail. But to quickly tell you right now, a conditional is true just in case the antecedent phi is false or the consequent psi is true. So a conditional is true whenever the first thing phi is false or the second thing psi, the consequent, is true. Another way of putting this is that a conditional is false just in case the antecedent phi is true and the consequent psi is false. So that is to say that the only case in which a conditional is false is when the antecedent phi is true, but the consequent psi is false. And we represent this with the following truth table. So here, in the case where phi is true and psi is false, we have that the overall conditional is false. But in all other cases, we have that the conditional is true. So in the way that we're understanding this conditional, what the conditional says is that it's not the case that the antecedent is true and the consequent is false. And that is the meaning of our conditional. Now the biconditional, phi if and only if psi, that is true just in case both sides, both the left-hand and right-hand side, have the same truth value. So the biconditional is false just when phi and psi differ in their truth value. And that is represented with the following truth table. So when both phi and psi are true, the biconditional is true. And when both of them are false, the biconditional is true. Because again, the biconditional's truth involves both sides having the same truth value. So there's those the two cases in which both sides have the same truth value is when they're both true and when they're both false. So that's why in these two cases we have the true here. And in these two middle cases, we have that phi and psi differ in their truth value. And in those cases, we say the overall biconditional is false. So in a couple weeks, we will talk much more about meanings or semantics of what we just covered. And these truth tables are that we just looked at, like for instance here, are an essential part of understanding the semantics for sentential logic. And we will come back to these and discuss them in much more detail. But for now, I just want you to have a basic understanding of the meaning of these symbols in our language, which might help you do your translations.